Hi, in this video, I will be showing you problem number 23 of chapter 7 section 4. Evaluate the integral 17 over x minus 1 times x squared plus 16 dx. Look at the integrand, which is a rational function where the denominator consists of a linear factor and a quadratic factor. This quadratic factor cannot be factored into a product of two linear factors, so it is irreducible quadratic factor. So in this case, we are going to write the integrand as 17 over x minus 1 times x squared plus 16 as a over x minus 1 plus bx plus c over x squared plus 16. So if the denominator is linear, the numerator will be just a constant. If the denominator is quadratic, which is of degree 2, then the numerator has to be a linear one, so which is bx plus c. This is the case when the denominator is irreducible quadratic factor, which is cannot be factored as product of two linear factors. Now we're going to multiply both sides by the LCD, which is x minus 1 times x squared plus 16. Now we will have 17, which is a times x squared plus 16 plus bx plus c times x minus 1. So either we can compare the coefficients and come up with simultaneous equations on a, b and c, or we can give plug-in values for x and compare the two sides. So we will substitute x equal to 1, then 17 equal to a times 1 plus 16, that would be a 17. Then the second term would go away. So it is a equal to 1. So we got one value, one unknown. Then we will plug in x equal to 0. So 17 equal to a times 16, x equal to 0. So we will have c times negative 1. So we get 16a. A is known. So we can plug in the value of a, which is equal to 16 minus c. So c would be equal to negative 1. And we can compare the coefficients of x square. So we get there is an x square with whose coefficient is a. There is an x square here whose coefficient is b. So we get 17. On the left hand side there is no x square term. So 0 equal to, so compare the coefficient of x square. That's what we are doing on both sides. There is no x square term on the left hand side. On the right hand side, the coefficient will be a plus b. But a equal to 1, so 1 plus b equal to 0, or b equal to negative 1. So the integrand, which is 17 over x minus 1 times x squared plus 16, can be written as 1 over x minus 1, then plus negative x, negative 1, because b is negative 1 and c is negative 1. So in 1, if we substitute the values of a, b and c, we get negative x, negative 1 over x squared plus 16. Now we are going to integrate all these, the two expressions that we found. So it is integral 17 over x minus 1 times x squared plus 16 dx, which will be integral 1 over, if I call this as equation 2, so from 2 we get that to be 1 over x minus 1 plus negative x, negative 1 over x squared plus 16 dx. This is from 2. So integral I would be the integral of these two terms. So 1 over x minus 1 dx plus integral negative x over x squared plus 16. You break them into two integrals. Then plus negative 1 over x squared plus 16 dx. So now it becomes three integrals. So if we integrate the first one, it is ln of absolute x minus 1. Then this part we are going to do by substitution, so we will call it just I2. We will integrate that separately. And this one is by the formula. I can take the negative one out, so it looks like I'll call it I3 for this time being, so negative 1 I3. Then we'll evaluate I2 and I3 separately. I3 is just a formula. I2 needs to be done by substitution. So what is I2? I2 is, here also I can actually remove the negative sign. So if I remove the negative sign, it will become negative I2. Then I2 is simply x over x squared plus 16 dx. So if I substitute x squared plus 16 equal to u, then du would be 2x dx. This is the substitution we would use. So I2 alone would be, I'm going to call this a step 3. We are going to get back to the step and then plug in the values of I2 and the I3 that we are going to evaluate just now. So it is integral x dx on the numerator. So x dx is half of du. So it is du over 2 times u in the denominator. So 1/2 ln of absolute u. So 1/2 ln of absolute x squared plus 16. That is I2. Then I3, which is integral 1 over x squared plus 16. The symbols of formula 1 over x squared plus a square, which will be 1 over a tan inverse of x over a. So here a square is 16, so a will be 4. So it is 1 over 4 tan inverse of x over 4. So I would be equal to ln of absolute x minus 1 in step 3 minus I2. I2 is 1/2 ln of absolute x squared plus 16. Then plus 1 over 4. I3 is minus I3 here. So minus 1/4 tan inverse of x over 4 plus c if this was an indefinite integral. Keep in mind, as this is an indefinite integral, there is no limit or a lower limit or upper limit. So we have to add the additive constant c in the answer. Hope this video helps.